welcome to video number 4, lesson number 4, systems of linear equations. This is the second video in the series around, or the 2 videos on the algebraic techniques. This one is going to focus on the method of elimination rather than substitution, and so method of elimination, at least how I see it, is a lot easier. It's my preferred method. If I had a choice, I would solve all of these systems using elimination, just because to me it's easier rather than solving in terms of one variable, substituting in, and then substituting the solution back in to get both solutions. In elimination, we want to basically create 2 equations that look similar in some aspects. So whether they both have the same coefficient of x or they both have the same coefficient of y, perhaps the sign is different, that's okay. But once we have them looking similar, we want to add or subtract the 2 equations, and then what's going to happen, as soon as we add or subtract, one of the equations or one of the variables will disappear. And so we already have an equation in one variable that we just can solve for, and then we just go back and we substitute for the second one. So it's a lot quicker and a lot easier in my eyes. So let's look at class example number 1. I'm actually going to go through class example number 1 to 4 with you, and then class example number 5 is a little bit repetitive, and we don't have to worry about trying to complete questions similar to class example 6. So 4 examples should be lots. So let's get started. Consider the system of equations. 2x plus 7y equals 13. 3x minus 7y equals 2. Remember how we said we want the equations to look similar and we want them to have the same coefficients, except for maybe a different sign. Here on the y, that's a positive 7 coefficient. Here on the y, that's a negative 7 coefficient. And so it says add the 2 equations to eliminate the variable y. Now, these are lined up perfectly. X over x, y over y, their coefficients lined up, numbers over numbers, equal signs over equal signs. That's kind of the format you want when you're going to create or try elimination. And so I can see here, I'm just going to like draw a line as if I was adding these together. And now I'm just going to add down the row or down the column. So 2x plus 3x is 5x. Positive 7y plus negative 7y, that's 0, so this is actually gone, equals to 13 plus 2 equals to 15. If 5x is equal to 15, we can divide by 5 now, and we already have our answer for x. That x must be 3. We can go back to our equation of our choice, doesn't matter which one, and we can solve for y. I'm going to choose the first one just for ease or convenience. So 2x plus 7y is equal to 13. I know now that x is 3. So wherever I see x, I'm going to write in 3. So I have 2 times 3 plus 7y equals 13. 2 times 3, that makes 6. Plus 7y equal to 13. And so now I'm going to move this 6 over, or take away the 6 to get 7y alone. 13 minus 6 is 7. 7y equals 7. If I divide by 7 on both sides now, y equals 1. And so I would go over and state my solution again, always as an ordered pair, or I'm going to list both. I'm going to say x equals 3, y equals 1. That's my final answer, and I could go ahead and verify that. Okay, so when we see coefficients with the same number but maybe different signs, adding them will eliminate that variable because you're adding a positive to a negative and the numbers are equal. So that'd be like saying positive 3 plus negative 3, or positive 5 plus negative 5. And that works out pretty nicely in eliminating that. Now, here's another example. It says consider the system of equations 2x plus 6y equals 6 and 2x plus 3y equals 4.5. Now I'm noticing again something they have in common. They both have a 2x, and so if I was just to go ahead as I had last time. I said, okay, they're the same. Let's add. And if I add, 2 plus 2 becomes 4, 6 plus 3 becomes 9, and I got numbers on this side. So in fact, I didn't get rid of my system of equations at all. So in this case, because they don't have the different sign, I want to eliminate x by subtracting them rather than adding them. So I'm going to draw the line under, I'm going to subtract these. They're all lined up. X's, Y's, numbers. 2x minus 2x is 0. 6y subtract 3y is 3y. 6 minus 4.5 is 1.5. Keep my equal sign there. If 3y equals 1.5, I can divide by 3, and I'll see y is equal to 1.5 divided by 3, which will be 0.5. And if we math fraction this, we get 1/2. And now that I have y, I get to choose any equation I want to solve for x. So I'm going to go back up. I usually choose the top one just because it's easier to see, and then that way I won't forget which one I was reading from. 2x plus 6y equals 6. Now that I know that y is 0.5, I'm going to plug that in. Or 1/2, either way, it doesn't matter. 2 times 1/2, whoops, made an error there. X is not 1/2, y is 1/2, so I'm going to try that again. 2x plus 6y is 1/2, 6y, 6 times 1/2 equals 6. This tells me 2x plus 6 times 1/2 is 3 equals 6. Take away the 3 to get 2x alone. And so 2x equals 3, dividing by 2, x equals 3/2. And so again, I've got my solution, x and y. I'm going to go over and state what they were. X is equal to 1/2, y equals to 3/2, and I kind of mark that down. That's an ordered pair. That would have been the point of intersection on my graph, but it's the x and y that makes both of these equations true, satisfies both of them. So we can see elimination if you can set up a way of lining up your x's, your y's, and trying to find similarities in the coefficients. You can either add them if they're opposite signs or subtract them if they're the same signs, and it helps you eliminate a variable really, really quickly compared to substitution. Okay. So in class example number 3 and 4, we sort of cover the case of, well, not all systems of equations have those similarities. Can we create those similarities? Can we build our equations so that we can use elimination? We don't have to use substitution. The answer is yes. And so when we're looking at a system such as the one here, the first question in A is going to sort of lead us to what we should do next. It says, well, does adding or subtracting these equations eliminate either variable? And so if I go 2x plus 4x, I'm at 6x, and positive 3y plus negative y, that would be positive 2y. So in fact, we didn't eliminate any variable by adding. And if you go to subtract, you'll go 2x minus 4x, negative 2x, 3y subtract negative y, so 3 subtract negative 1, positive 4, and in fact you still didn't eliminate x or y. And so as long as you're following that rule, what you do to one side you can do to the other side. We can choose to multiply numbers that would help, but multiply by numbers that would help us set this up. And so it says multiply the second equation by 3. So here's my second equation. Can you multiply, or what will happen if you multiply the whole equation by 3? And so if I take the first equation, I'm just going to rewrite 2x plus 3y equals 4. And then I write, or I multiply by 3, and I go 3 times 4x, that's 12x. 3 times negative y is negative 3y. Equals 3 times 22, which is 66. Now, by multiplying by 3, I've purposely created a coefficient in front of y equal to -3, and now I can add the two equations, because if I add them, a +3 and a -3 are going to cancel, they're going to go to 0. So if I add them together, I will go 2x plus 12x is 14x. 3y plus -3y now is gone, that's at 0. 4 plus 66 is 70. And so it says go ahead and solve the system. So I'm going to first solve for x, because now I've eliminated my variables by doing the adding, the elimination step. 14x equal to 70. Well, 70 divided by 14, that is 5. X equals 5. And so the last part of this, I need the other half of that pair, that xy pair. I gotta go back and solve for y. Any one I choose the first one just for convenience. That 2x plus 3y equals 4. Now that I know x is 5, 2 times 5 plus 3 times y is 4. That makes 10. Plus 3y equaling 4. If I take away the 10 on both sides, 3y equal to -6. And my very last step, dividing by 3, y equal to -2. And just by habit, I like to go up and state what is x, what is y, so that I have my final answer stated as a solution to this system. Okay, so then the question you might be having is, okay, well, how did you know to multiply by 3? Could you have gone another way? And the answer is yes. We chose to multiply by 3 because we looked here, saw a 3, saw a -1. If we multiplied the -1 by 3, we get a -3. So we purposely did that so we could add them. And so you get to choose. Maybe you didn't want to match up y. What if you wanted to match up x? You're saying, what could you do to 2 to get 4? And so you can go back to your original system. You can multiply the whole top equation by 2 if you wanted to get the same result. Let's try it down here. So we get, what if I took that whole top system, or that whole top equation, and multiplied it by 2? And I'm just going to rewrite what's below. I don't want the 3 there. That was from last question's work. So the original was 4x minus y equals 22. And so now if I am choosing to change the x's or to match the x's, I had to multiply by 2 so that 2 times 2 equals 4. And then I have to be careful that I don't forget not just to multiply by the 2, to multiply 2 by everything. 2 times 3 is 6y. 2 times 4 equals 8. And so often that's where our error is that we're really quick to go through and multiply by something that we can see can match, but we forget most often the number on the other side, the equal sign, or we forget the y, or something like that. So 4x plus 6y equals 8 now is the equation. It is still true. We have not changed the equation. We've simply multiplied it, left side and right side, by an equal number, so that left side should still equal right side. When we go to solve this system, we don't want to add because we can't eliminate anything by adding. But if we subtract, if we choose to subtract to eliminate, 4x minus 4x will be eliminated. And so we got to watch our double negative here. +6 subtract -1 is +7. 8 subtract 22. 8 subtract 22, that would be -14. And so dividing by 7 on both sides, y equals -2. And so opposite to what we had done last time, because we had eliminated y, we had first found x. Now that we've eliminated x, the first sort of part of the solution we have is y. We have to go back. I'm just going to go up here. We have to go back now and try to solve one of these equations for x using the fact that now y equals -2. And so maybe I'm going to choose the second one. just to try it out since I used the first one last time. So 4x minus y is 22. Then we can state, well, y is negative 2, or sub in negative 2. Now I'm going to watch here. Minus y minus negative 2, that's equal to 22. 4x, negative 4x plus 2 equals 22. And so now if I subtract 2, I'll get 4x equals 20, which dividing by 4, x will equal 5. And so it's the exact same solution that I had up above. X equals 5, y equals negative 2. It's just a different way to get there. So rather than maybe noticing the 3 and the negative 1 and trying to make them match, we notice that 2 and 4, that 4 is a multiple of 2, and we just times by 2 up top. Okay, so class example number 4 is the last example that I'm going to do with you, because we've seen the adding, we've seen the subtracting, we've seen fraction answers, and so I want to walk you through now, instead of them telling us what to do, what do you do if you come across a question and you want to use elimination, but it's not obvious that you can. So you're gonna create a system that you can solve. And so if I see 5a plus 3b equals 3 and 3a minus 7b equals 81, I'm just going to go down here and rewrite these so that I have them underneath my heading there. Okay. And what if I wanted to solve this system by eliminating b? Solve this system by eliminating b. Okay, well, I can't, right away, I don't want to add, because adding won't get me to 0. Positive 3 and negative 7 is not 0. Subtracting 3 minus negative 7 is also not 0. And so I might be like, okay, well, I'm going to go back up and I'm going to multiply by a number. I'm going to multiply this 3 by a number so that it equals 7. Well, 3 times a number is not 7 unless I'm going to deal with fractions, and I don't want to go there. So I'm trying to say I want to create a similarity, something common between positive 3 and negative 7. And I know 3 and 7 are both factors of 21. So I can do trial and error a little bit here, but if I decide to multiply the first equation by 7 and the second equation by 3, now 7 times 3 is 21, 3 times negative 7 is negative 21. So I'm creating almost like the same process we would use for a common denominator. I'm creating two coefficients that will be the same without, of course, changing how a is related to one another. And so if you remember to multiply all of these appropriately, like to every single one, and 3 multiplied to every single one, you're not going to run into that error. So let's go ahead here and multiply 7 with each coefficient in the top equation. So we're going to have 7 times 5, 35a, plus 7 times 3, that's 21b, equal to 3 times 7, or 21. And I will go down on the bottom. 3 times 3 is 9a. 3 times negative 7, negative 21. b equals 3 times 81. 3 times 81 is 243. And so I've created a system in which I want to eliminate b, so I've made the coefficients on b the same, and now I just have to decide if I'm going to add or subtract, and I can see a positive and a negative. If I add those, they'll go to 0. And so 35a plus 9a would be 44a. 44a equal to 21 plus 243 plus 20 would be 263. One more would be 264. 44 times a equals 264, divide by 44. A equals 6. And so I have A. I do have to go back, choose one of the equations, and try to get B. So it doesn't matter which one, top or bottom. Original, probably easier than dealing with larger coefficients. I'm going to go back to the top one. 5A plus 3B equals 3. I know now that A is 6, so I can substitute in A. I can substitute it as 6 wherever I see A. So that 5 times 6 times 3 times B equals 3, which means 5 times 6, 30 plus 3B equals 3. Getting your numbers on one side, leave your letters on the other. I'm going to take away 30, so that 3B equals negative 27, which means B must be negative 9 if I divide by 3 on each side. So I have A equals 6, B equals negative 9, and so feel free always to pause these videos, go back, replay them. By the end of the unit, you're going to be so fluent at solving these 2 or 3 step equations because we do them all the time. And so we got to remember, you're going to get rid of your numbers first, numbers on one side, letters on the other, divide by the coefficients. Okay. So going back up to that original system, these ones right here, says, can you solve the system by eliminating A? And so it's kind of back to the common denominator thing. What could I multiply each equation by? 5 and 3 there. What could I multiply those numbers by so that they would go to the same numbers so that I could eliminate them? And so I'm going to rewrite our system down here so we can see what we're going to multiply by. And so I've just copied down the 2 systems from up above. And if I was trying to find a common denominator between 3 and 5, I would say the common denominator is 15. So I'm going to do the same thing here. I'm so sorry. Okay, I want to create a common coefficient of 15. How do I do that? Top equation multiplies by 3. Bottom equation, I can multiply by 5, would give me 15. Okay, and so 3 times 5A would be 15A. 3 times 3B would be 9B. 3 times 3 is 9, and so really watch that number one error there is to miss multiplying everything in the equation by the number. We just have a habit of multiplying the first coefficient and leaving the rest. And so I'm going to go down at the second equation. 5 times 3A gives me a 15A. I did that on purpose, right? I created that common coefficient. 5 times negative 7 is negative 35. B. 5 times 81, well, that's going to be a bigger number. 5 times 81 would be 405. And so the numbers do get quite a bit larger when you have to multiply both equations, but you solve them just the same. And so now I can see I have the 15A and 15A. I don't want to add because they have the same sign. I'm going to choose to subtract in this system to eliminate A because I know 15A minus 15A is 0. I got to watch on the subtraction though. That double negative can get me. So positive 9 subtract negative 35. Positive 9 double negative add 35 would be 44. B. 9 subtract 405. 9 minus 405 is going to be negative 396. You can verify that on your calculator. Again, if 44 times the number equals negative 396, dividing by 44 will get me the number B equals to, and calculator says negative 9. Okay, and so once I get B first, because I eliminated A, I have to go back and I have to figure out what A is. I get my choice. Last time I used the first equation. This time I'm going to choose the second. So I'm going to say any of the two I want. I don't have to do both. 3a minus 7b, pulling this from up here, 3a minus 7b equals 81. Now that you know that b is negative 9, sub in b, so replace b with negative 9, and then solve a two-step equation. So I have negative 7 times negative 9, that's positive 63. I'll have 3a plus 63 equals 81. And so I'm going to go now and say, okay, well, in these two-step equations, I have to subtract first, minus 63. So that 3a equals 2, that would leave me with 18. And very last step, divide by 3, a equals to 6. And so I can see same solution as I had up above, a equals 6, b equals negative 9, and I can go ahead and verify that if I wanted to be 100% sure. I could even go and check on my calculator if I wanted to by converting these to x and y and graphing the y equals and finding the intersection. But when we're focusing on the algebra, we can use either substitution or elimination, and so I hope you've found elimination a little bit easier than substitution, and that you choose to use it maybe more often or get better at using it than substitution. Okay, you can go to Google Classroom, you can find your assignment there, you can print your exit slip, and you can get to work.